let's draw the structures for the following alkenes. I'm going to draw the structures both in condensed form as well as in bond line notation. Let me first draw the structure in condensed form. For molecule 1, the root word is hex. That means we have 6 carbon atoms in the parent chain and the position of the double bond is at 2. Therefore, let us first draw the backbone, 6 carbon atoms. So 1, 2 and then double bond at 2 position and then 3, 4, 5, 6. Number it 1, 2, 3, 4, 5, 6. Put the methyl groups at 2 and 3 position. There is a bromo substituent at position 6. So let's do that also. Now to satisfy the valency of carbon, let us fill the hydrogens. At position 1, we have to put 3 hydrogen atoms so that the carbon valency will be satisfied. At 2 and 3, the carbon valencies are already satisfied. At position 4, put 2 hydrogen atoms. Position 5, put 2 hydrogen atoms. And 6 also, put 2 hydrogen atoms. The same structure in bond line notation would look like this. When you hit the marker or pen, that is your position 1. So then 2, 3, 4, 5, 6. Number it so that we will not be making any mistakes. 1, 2, 3, 4, 5, 6. We have a bromo substituent at 6. Let's draw that. And then methyl group at 2 as well as methyl group at 3. We have a double bond between 2 and 3. Let's not forget that. That's how the structure will look like in bond line notation. Let's go to structure 2. Here the root word is hept. That means the parent chain contains 7 carbon atoms and the position of the double bond is at 1. Therefore, let's draw the carbon backbone first. 1, 2, 3, 4, 5, 6, 7. Number it. We have a chloro substituent at position 4. We have a bromo substituent at position 5. Now let's fill the hydrogen atoms to satisfy the valency of carbon. Here we should have 2 hydrogens. Here 1 hydrogen. Here 2 hydrogens. Here 1 hydrogen. Here also 1. Here it should be 2. And here it should be 3. The same structure in bond line notation would look like this. 1, 2, 3, 4, 5, 6, 7. If the number of carbon atoms are odd, the cone will end perfectly. This is also one of the ways you can cross check. If the number of carbon atoms are odd carbon atoms, cone will end perfectly. If it is even number of carbon atoms, then the cone will not end perfectly. So this is something you should keep it in mind so that you won't be making any mistakes. So here we have 7 carbon atoms in the parent chain, so the cone ends perfectly. Now put the double bond between 1 and 2, number it, put the chlorine substituent at position 4 and then the bromine substituent at position 5. That's how the structure will look like in bond line notation. Let's go to structure 3. Here we have an octene chain as our parent chain and the position of the double bond is at 4. So let's draw the backbone first. 1, 2, 3, 4 and then at 4 we have the double bond. 5, 6, 7, 8 and then 2, 5 dimethyl. Let us first number it. 1, 2, 3, 4, 5, 6, 7, 8. At 2 position we have a methyl group and 5 position we have a methyl group. Let's fill hydrogens at other places to satisfy the valency of carbon. Here it should be CH3. Here it should be 1 hydrogen. At position 3, 2 hydrogens. Position 4, 1 hydrogen. Position 5, the valency of carbon is already satisfied. Position 6, 2 hydrogens. Position 7, 2 hydrogens. Position 8, 3 hydrogens. Now let's draw the corresponding structure in bond line notation. 1, 2, 3, 4, 5, 6, 7, 8. Number it. 1, 2, 3, 4, 5, 6, 7, 8. Put the double bond between 4 and 5. 1 methyl group at 2 position. 1 methyl group at 5 position. That's how the structure will look like in bond line notation. They did not say whether it is cis or trans, and therefore Let us not worry about that. Let's go to structure 4. 4-methyl 2-pentene. We have a pentene chain and the double bond is at 2 position. Therefore, let us first draw the pentene chain. 1, 2, carbon-carbon double bond, and then 3 and 4 and then 5. Number it 1, 2, 3, 4, 5. Put the methyl group at 4 position. Let's fill the hydrogen atoms at other places to satisfy the valency of carbon. Here it should be CH3, 1 hydrogen at position 2, 1 hydrogen at position 3, 1 hydrogen at position 4, 3 hydrogens at position 5. The corresponding structure in bond line notation will look like this. 1, 2, 3, 4, 5. At 2 position we have a carbon-carbon double bond, and then at 4 position we have the methyl group. Number it 1, 2, 3, 4, 5. That's how the structure will look like in bond line notation.